Okay, here are some examples first before we go through this. I'll just go through this section of your notes. This is on page 16. So just kind of looking at Le Chatelier's principle and the different types of reactions and the change to the system. Okay, and so again, so for all reactions, increasing any reactant concentration or decreasing the product will shift towards the products. Decreasing the reactants or increasing the products will shift towards the reactants. Using a catalyst doesn't change any like their direction. It just gets to equilibrium faster. Okay, if you look here, none of them have any effect on the equilibrium constant. For exothermic reactions, if we increase the temperature, that means the temperature is, or like the energy would be on the product side. So it's gonna, if we're increasing it, it's gonna shift towards the reactants. If we decrease the temperature, it would shift towards the products. These are the only ones, if you look here, they're the only ones that will actually affect our equilibrium constant. Okay, and you just got to think of which way it shifts. If we're shifting towards the reactants, the equilibrium constant decreases. Shifting towards product, it's going to increase. Okay, for endothermic reactions, so yeah, for endothermic, increasing temperature. Again, you got to think temperature or energy would be for endothermic reaction on the reactant side. So increasing temperature, it's going to shift towards the products. Decreasing temperature towards the reactants, and again, the way it shifts, if we go towards the product, Kc will increase. If it goes towards reactants, Kc will decrease. Okay, if we have the equal number of reactants and products in the gas molecule, then changing the volume doesn't matter. So like that's where we have it balanced and with equal number on both sides. It doesn't matter if we change the amount of like the volume of the container or adding anything or adding a non-reactant gas. Neither of them have any effect. Okay, if we add more gaseous product molecules than reactant, or so if we have more product molecules and reactants, if we decrease the volume, again, it's going to want to shift, so we're increasing the pressure, so it would shift in this case towards the reactants. One thing to note is like if we change the pressure by adding a non-reacting gas, it has no effect. Okay, and so whenever we like, so you'll get examples where it'll be like adding argon gas, which you'd think would increase the pressure because there's more molecules, but really it has no effect, no change. All right, you can kind of read through these if you want. Like we kind of went through them in our last set of notes. So here's some examples on how to kind of answer these problems for Le Chatelier's principle. For each the following chemical systems at equilibrium, use Le Chatelier's principle to predict the effect of the change imposed on the chemical system. Indicate the direction in which the equilibrium is expected to shift. Okay, and so for these, you're just looking at the problem. So it says here, the container is heated. So really what's happening is we're increasing our energy. If we're adding more energy, it's going to shift towards the products. Whenever you increase something, it has to balance out by shifting and making more of something else. Okay, for this one here, a few crystals of sodium hydroxide are added to the container. So really what we're doing is we're increasing the amount of sodium hydroxide. Okay, since we're increasing this, okay, this will increase, so it's going to shift towards reactants. Again, like for this one, since we're shifting towards the product, our Kc would increase. This one, again, only with energy is Kc changed. This one, Kc unchanged. Okay, we have calcium carbonate and energy producing calcium oxide and CO2. So if we take some of the CO2 out, so we're going to decrease this, okay, which means it's going to shift towards, to make more of it, shift towards products. And our KC again will stay unchanged. Okay, and the last one here, so we have acetic acid, and it's broken down to its ions. So a few drops of pure acetic acid are added to the system. So we're increasing this amount. Okay, so again, it's going to shift towards products. Okay, and our KC will remain unchanged. Okay, it doesn't ask for those in these questions. I just want you to get in the habit of kind of realizing that, like, the only thing that'll change our KC is when we change our heat. Okay, and our last page of our chapter 15 notes. Okay, just kind of showing what these look like on a graph when you're doing these changes. So like you might, like on your assignment, I believe you're asked, like you're given a graph like this and it says what happens here, what happens here, and so on. Okay, so you have to be able to predict this. So this one here, okay, this first change, so this is our, each one of these shows our equilibrium and what's happening. Okay, so this is, we have iron, and I don't know what that's called, but when they go together to produce this ion, this is the reaction that's happening. If we add more iron, so that's what it's showing here, we're adding more iron, okay, then iron needs to decrease, which means our other ion, this would decrease, so our other reactant and our product would increase. So that's what's showing there. Okay, here, if we add more of this SCN minus, okay, SCN minus, again, it's going to cause a shift. So we're adding, this would be our SCN minus, we're adding more of it, which means that we're going to use some more of our reactants to produce more products. In this one, we're adding more of our product. Okay, and so if we add more of this straight line showing more, we're adding more of it, which then it balances out like to produce our equilibrium. So it's going to reduce it and make more reactant, okay, over time. And this is a diploma type question based on the Chatellier's principle. Again, you don't have to worry about the diploma this year, but just to kind of show you the questions that you can get like on your unit exam, things like that. So an equilibrium system is established in a 1 liter flask at 800 degrees Celsius as represented by the following equation. And it tells us our Kc is 1.9. Which of the following graphs represents a change in equilibrium system at time x that results, or as the system is heated? So if the system is heated, again, this is increasing. This, we're adding energy to it, which means there's going to be a shift towards the reactants. So if we look here, we have to get more PCl3 and Cl2. So if we look at this first one, the PCl3 is going down. That can't happen. We need more of it. Okay, this one again, it's going down. So this one, okay, so PCl3 is increasing. That's right. Cl is increasing, but if we're making more reactant, there will be less product. So this can't go up. So that's wrong. So this is our answer. Yeah, we're making more reactant, and less product. All right, hopefully these examples help you with your homework assignment 3.3. If you have any questions, feel free to email me. Yeah, I'm happy. Like, I know lots of you said you don't really like the Google Hangout thing, and I know I've tried a couple times and nobody really logs on. Okay, but I'm happy I can do questions as videos. Like, if you're like, I don't know how to do question 3 on assignment 3.3, I'll make a short video just like this, where going through the process of what I do to answer that question. I'll do the whole assignment if you want. Just let me know. I won't do anything unless like, you kind of ask for it. Okay. But yeah, just, and also the answer keys are all posted, so you can always check on that. And if you can't solve from that, like make sure you understand how to do it. You aren't just copying from my answer key, or that's not going to help you when it comes to any quiz or test.